Good afternoon and once again welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamotho, and today I want to learn something in Pure Mathematics 2, International Advanced Level Mathematics, and in topic number 2 I want us to understand example 10, and the subtopic is use tangent and chord properties. First of all, before we even look at example 10 itself, I would want to remind ourselves two properties like this. That if we happen to have a circle, that could be a circle, and there is a tangent to the circle, the radius of the circle coming from the center O meets the tangent at right angle. This is the tangent and this is the center of the circle. A tangent to a circle is perpendicular to the radius of the circle at the point of intersection. We know that. We could be having another circle like that, and we happen to have a chord, and that chord is meeting with another chord that is coming from the center O, and it is very telling because this is a perpendicular bisector. Perpendicular bisector means it is bisecting this chord into two equal portions, and this chord touches the circle at two different points. We can call that A and B. So that the perpendicular bisector of a chord will go through the center of the circle. So we must have those properties in mind even as we understand example 10. That a tangent to a circle is always perpendicular to the radius of the circle at the point of contact. And a perpendicular bisector of a chord must always be passing through the center. Those two properties must be understood. And in example 10, we are told the circle C has equation x minus 2 squared, y minus 6 squared is equal to 100. Verify that the point 10, 0 lies on the circle. The point 10, which is point P, 10, 0, lies on the circle. Please note, these are the coordinates of the point P in terms of x and y. That means the value of x at P is 10 and the value of y at P is 0. So if it lies on the circle, it must be satisfying the equation of the circle. And since this is the equation of the circle, which is basically x minus 2 squared plus y minus 6 squared is equals to 100, any point on the circumference of the circle will display or will obey this particular equation. If we substitute any value of x and any value of y, and then it agrees or they agree with this equation, then it verifies that the point lies on the circle. So what do? Substituting 10, 0 in the equation of the circle. We substitute that in the equation of the circle, and x is 10, y is 0. What does that mean? 10 minus 2, which is 8 squared, 10 minus 2 plus y minus 6, which is minus 6 squared. We realize that this is 64 plus 36, which is basically 100. And since it agrees with the solution of the circle, then this is verified. This already tells that the point 10, 0 passes through the circle, or it lies on the circle. It is verified. That is just like that. If you look at part B of the question, we are asked, find an equation of the tangent to C at the point 10, 0, giving your answer in the form of the equation of the tangent. The reason why I had to introduce this is so that you can actually see the clear picture of the tangent and how that tangent relates with the radius of the circle. And we have a scenario, we have a picture that is reflected in our question. That is the point P, 10, 0. And this is the point, the center of the circle, which is, of course, you can see from the equation of the circle, the center of the circle is 2, 6, 2, 6, 2, 6. If we drop that, then this is perpendicular, and we have been told that before. But since we have 2 points along the radius, we can easily calculate the gradient of the radius, which could be change in y over change in x, which is 6 over minus 8, which is minus 3 over 4. Change in y over change in x. And because the radius is perpendicular to the tangent, then the gradient of the tangent must be the reciprocal of this, of course with the opposite sign, simply because the product of the two gradients have to be -1. And of course it's going to be 4 over 3, it goes without saying. And having said that, we look at this tangent and again assume that it is passing through many other points, and one of the many points it passes is xy, and we are very sure that if we establish the gradient from this, then we will sure to be getting 4 over 3. Therefore, we can just talk about y minus 0 all over x minus 10 is going to give us 4 over 3. Cross multiplying, we have 3y is equals to 4x minus 40. At the end of the day, we have the equation, but we have to write it in terms of ax plus by plus c is equals 0. And in this format, we just have to bring 3y and on the right, so that we'll have followed the instructions. So at the end of the day, we have 4x minus 3y minus 40 is equals to 0, and that is the equation of the tangent to that circle. We have to leave our answer in the correct form. Yes, this property of the radius being perpendicular to the tangent has really helped us a great deal, because even if we would have been able to calculate the gradient of the radius, if we don't know the perpendicularism property between the radius and the tangent, then it was not possible to get the gradient of the tangent. But now that we know, we have used that property, which has brought us home very easily. So again, visit my YouTube channel, subscribe and share widely, and let us see how we can help each other out. All right.